Okay, continuing from where we left off, we're going to talk about cookies. So basically what cookies do is they provide a little bit of state information that helps out with some websites. So basically, um, many websites use cookies, and they're basically four components. There is the cookie header line of the HTTP response method. There is the cookie header line in the HTTP request message. There is the cookie file that's kept on the host that's managed by the user's browser. So when you go back to that website again, the browser will use that information. And that information, which is kept on the server, is linked to a back-end database at the website that now has that information on you. So how is this used? So we have an example where we have a user, Susan. She accesses the internet from her PC, and she visits a specific e-commerce site for the first time. When she makes her initial HTTP request at the site creates a unique ID and establishes an entry in its database for the users of that site, and it links that entry to that unique ID. So it basically becomes a record, and the unique ID is the unique identifier for that record on that e-commerce server's database. So let's take a look at what happens. So you have our user, Susan. She is on a client, and she goes to she only has one cookie saved on her local host, which is one for eBay that she went to before. She hasn't been on Amazon yet. She makes a request message. She goes on the Amazon.com server. The Amazon.com server creates a unique ID of 1678 for our user, and it creates a record in its backend database, and 1678 is the unique identifier for that record. The server, when it sends a response back, has an additional piece of information that basically says, hey, I've provided you, user, with this user ID of 1678. So when you go to the site, you can use this unique user ID, and the client can save that in the local browser. So later on, the client makes a request that says that provides that cookie user ID for that user. The web browser can provide a response as normal, and then a week later, that same user can go back to that URL. So what the browser does, when you go to that URL, it looks up to see, yeah, I have some cookie information for that browser, so I'll send my cookie ID to that user. So now different things, like say you're on that Amazon server and you have say you have a shopping cart saved, or you can track your Amazon transactions, all those things can get saved in that database, if that's something that you'd like to do. Obviously, cookies is an optional feature. You don't have to do that. So basically, cookies can be used to authenticate a user, make sure a user is authorized. Can be used for shopping carts, like we just said, for recommendations. So you go to some sort of e-commerce site and they track your purchases, and they say, oh, you bought thing X, you might like thing Y. They provide you recommendations and they can also be used to save a user session state, such as when you're using web-based email. Of course, one of the issues, of course, is privacy, because now you're kind of sharing a little bit of information about yourself to the rest of the world that people can find out about. So that may or may not be a good thing. But basically what this does is allows a web server to keep some sort of state about the user that can be saved over multiple transactions. So we're going to skip a couple of topics on HTTP, and we're going to move on to our next topic, which is the File Transfer Protocol, or FTP. FTP is one of the older internet or network applications. It's a very simple application. To be honest with you, it's not very secure. These days, a lot of hosts don't even allow the use of FTP. But certainly on a local secure network, FTP can be used. So basically, very simple setup at the at a particular host. You have some sort of user interface, can be graphical, can be command line, and you have your local FTP client. And what FTP does, obviously, is let you transfer files from some remote from an FTP server and access files on a remote file system. It's not the same as remotely mounting a directory. This is specifically moving files from the server to the client. As in most client-server models, the client initiates the transfer either to or from the remote host, and the server is basically the remote host where the remote file is either going to be placed or retrieved from. The RFC that defines FTP is RFC 959, and the FTP server works on port 21. So basically a very simple setup. Basically there are two different connections, a control connection and a data connection. So what happens first is the FTP client contacts the server at port 21. This is all done over TCP. IP, obviously, we don't want to lose data, so TCP, we want a reliable transport protocol. The client is authorized over the control connection. Usually some sort of username and password, usually as a minimum. Once the connection is allowed, the client can browse a remote directory and send commands over the control mechanism. Then, when the server receives a file transfer command, it is a server that opens up a second TCP data connection for the file to the client, and after transferring one file, the server closes the data connection. The server will open up another TCP connection to transfer another file. So we say that the control connection is out of band, so it's separate from data connections, and each data connection has their own TCP connection. And the FTP server maintains the state, the current directory, and early authentication. So since we have a situation where things can be manipulated at the server, we need to this has to be a stateful system, and make sure we have an authentic, an authentic user that is authorized to access and read and write from the server. And if something were to happen, we need to maintain the state if there was some sort of crash, so we can basically have some logging mechanism to go back and get back to a good state. So we need to know, keep track of who was logging in and when, etc. So basically some here are some sample commands and responses. For further reading, you can look in RFC 959. Everything is sent as ASCII text over the control channel, so the data transfer control information is human readable. The username, password that's sent across. There's the list command to return a list of the files in the current directory. You have the RETR or retrieve command to get a file, and the STOR command to store a file. So that's what happens on the client end. So the client sends those commands, and since it's using TCP, there's going to be some returns back and forth. So there's a status code from the server to the client. And these are also all defined in the RFC. So example, status code 331 says, yeah, okay, I accept your username and your password. 125 says, I have a data connection. I'm going to set up a connection is open. I'm going to transfer a file. 425 lets you know, hey, for some reason I can't open up a data connection. Maybe I've hit my limit on connections that I can open. And if there's some sort of problem, like I said, keep in mind, we'll talk about this more when we get to TCP/IP. We can realize that a file didn't transfer correctly, and if the server realizes that, it can tell them, hey, there was an error in writing the file. You need to go try and start this all over again. So there's some sort of unrecoverable error. That's how FTP addresses that, and it's up to the user to try to retransmit. Okay, that covers FTTP. The next thing I like to do is talk about electronic mail. There are a few different protocols, and there are different components in the email system. Of course, I'm sure everyone has used email, whether it's Microsoft Outlook or some web-based email. Maybe the web-based email, once you get past the HTTP messages, there are, basically that web-based email is just a user interface, and eventually there has to be a mail client that is communicating to a mail server. So basically the way it works in electronic mail, just like FTP, is an older protocol. It's one of the oldest ones as well. Obviously, email predates the World Wide Web. This basically goes back to the original internet back in the 70s. So basically, three major components to electronic mail. You have your user agents, and you have the mail servers, and the protocol to communicate from the agents to the servers is what we call Simple Mail Transport Protocol, or SMTP. So what the mail agent does is basically it reads the mail. It composes, lets you compose, edit, and read your mail messages. And then basically those messages that you compose or edit, when you send them out, you're going to basically send them to a mail server. So each user agent uses SMTP to communicate to the server, and the servers communicate with each other using that same protocol. So at the mail server, there is set up a logical mailbox that contains incoming messages for users. There is a message queue of outgoing messages to be sent. So this is not a real-time system. Basically, it's kind of like sending, a mail server is kind of like sending a letter to the post office. You send a letter to the post office, and eventually it'll get delivered. It's the same thing with a mail server. Eventually, a message will get delivered, but it's going to sit in some sort of message queue for some time. And SMTP protocol is used between the mail servers to send email messages. And so the client sends email using the SMTP protocol to a server, and the server receives email either from a user agent or from another server with the SMTP protocol. SMTP is defined in RFC 2821. It uses TCP because we have to have a reliable communication path. We don't want to lose our email. And we use well-known port 25. So there's basically a direct transfer from the sending server to the receiving server. So we're going to step through the whole process. But basically, you start off with a 3 phases of the transfer. There's some sort of handshaking that occurs between the client and the server. Then the message is transferred, and then the connection gets closed. There's a command response interaction similar to HTTP and FTP, where the server will send back responses that will have a status code, and everything is in ASCII text. Apologize for my typo, but messages must be in 7-bit ASCII, and that's kind of just a reflection on the age of the SMTP protocol. So here's a basic scenario. So you have Alice. So on her computer at her desk, she has some sort of user agent. It could be Microsoft Outlook, for example. To send a message to some email address. Her user agent is configured to send all messages to a particular mail server. So Alice, she works with some company, so Alice and everybody that works for that company use a particular in-house mail server. So her message gets sent to the mail server. Then and that's basically step 2. The mail server then places the message in its message queue. Then, when it's ready to send the message out, the mail server opens up a TCP connection with Bob's mail server. Then the SMTP client on Alice's mail server sends Alice's message over the TCP connection. Then Bob's mail server places the message into Bob's mailbox, and at some future point in time, when Bob invokes his user agent and he gets can open that mailbox, he'll see that message. Now, obviously, if you ever were on a phone call with somebody and you need a document, and you'll say, "Hey, can you email me that document?" Um, there's some obvious time delay between when you actually receive that document. It takes a while for the mail servers to send the email. It's just the the nature of how they work. Um, so they don't try to do it in any type of real-time format. It's basically it's designed to be slow. Timing is not a priority for mail servers, so it's definitely not an instantaneous transaction. So here's an example of how a simple mail transfer protocol interaction might look like. Some of these commands probably will not exactly work today because there's obviously not that much error checking, but basically you could have done this a few years ago at least. And it shows some of the basic commands and responses. So you start off with a server that is available, and then you have a client that sends a hello command, and then the server responds back with a 250 response that says hello, pleased to meet you. So it kind of lets you know that you have made a basic connection. Then the client sends the mail from command. The server authenticates that that's a good sender. Then the client says, "This is where I want to send my message to." The server authenticates that that's a good recipient. Then the client says, "Okay, now I can send my data." Then the server says, "Okay, when you send your data, you're going to end it with a dot on a line by itself, and then I'll know that your message is done." So the client receives that OK message, and it sends its data, putting a dot on a line by itself to indicate that the message is complete. And the server lets the client know that the message is in its queue. Then the client can quit, and then the server responds that it's closing the connection. So mail message format is as follows, and this is defined in RFC 822, a standard for text message format. So every so there is an RFC that mail messages have to comply with beyond the SMTP. So this is how messages have to be sent today. So this is on top of the from and receipt to commands. So there has to be a header, and there has to be a blank. The header has to contain a to, a from, and a subject. At least those data elements, they can be the subject can be blank. Then there's a blank line, and then there's the body of the message. So that's in modern times what the message has to look like. So we talked about SMTP. So what SMTP does is delivers the mail from the user agent to a server, and then from the sender server to the receiver server. The user agent uses a different protocol to pull the data off the server. And if you're running, say something like a Microsoft Outlook, you might be using either POP or IMAP. If you're using a HTTP-based email service like Gmail or Hotmail or Yahoo Mail, you can use HTTP to pull the data. So basically, POP, which is defined in RFC 1939, it's called the Post Office Protocol, and it's for authorization and download. IMAP, which is a little bit newer, defined in RFC 1730, has more features. So you're basically your Outlook will use POP or IMAP, and your Hotmail or Gmail will use HTTP to retrieve the data from your mailbox on the mail server. So here's some basics of how the POP3 protocol uses. So there's an authentication phase where the server lets, once the mail system comes up, the server lets you know that it's ready. The client can send some username and password, and there's a response back from the server that lets you know that it recognizes username and password, responding either with a plus OK or negative error. And then there's the transaction phase where the client gets a list of the messages in the mailbox, and then it uses the retrieve command to retrieve one of the messages that get sent. It can send a delete command to delete a message from the mailbox. And then finally can use a quit command to quit the transaction. So what's some of the differences between POP and IMAP? So POP3 uses a download and delete mode. One of the disadvantages of that is Bob cannot reread the email if he changes clients. So basically, you basically actually physically store the email on a particular client, so it's no longer stored on the it can be set up so it's no longer stored on the server, so it's not going to be available for multiple clients. There is to do that, there's a download and keep that basically just sends a copy to a client, so you can send keep the email on the server and then send the copy to multiple clients. And POP3 is stateless across sessions, so it doesn't keep track of each session and what you accessed the last time. It's whatever transactions you do, it's only relevant for that session. IMAP, being a newer protocol, has some additional features. IMAP keeps all the messages in one place at the server, so you're never in a situation where changing the client is going to impact your ability to access the message. It allows users to organize messages in folders, so you can have folders on the server, and you can also have folders on the client machine as well. And it keeps the user state across sessions, such as the information about the folders and which messages were saved in which folders. So every time you go back again all that information stays the same. Okay, why don't we take a break, and the next thing we'll cover is domain name system.